Thank you. I'm Chris Nawalaniec with Stedman Machine Company, and I'm going to spend about the first 10 or 11 minutes just giving an overview of the different types of size reduction machines used in the North American brick industry, some of the fundamentals of size reduction, and then the cost and product quality implications. And then John Hewitt, the assistant plant manager from Interstate Brick in West Jordan, Utah, will spend the next 20 minutes kind of doing a case study based on their actual plant experience. So the fundamentals of size reduction, very basic. Forget about the types of machines. It's just adding energy to material to make large pieces smaller. So that's just the basis of it. Then different types of machines are in use and exist to do that most efficiently, to most efficiently put the energy into the material and get the desired product out at the lowest possible cost. Most of the people in this room were academically trained probably to make brick, and I don't find that the grinding room is the favorite place to hang out for most of the people in the brick industry, but it is a necessary evil. And it's also something that we're very passionate about because getting off to a good start with your raw materials is important, and we've heard that in a couple of the previous presentations already. So being consistent in how you prepare the material does affect the consistency of your product. And then the equipment choices vary depending on the products you're making. And also the equipment choices will vary based on your raw materials. So even though there's a lot of common equipment in use, the combinations can be different, and testing is a very important element. So even though a lot of the same equipment is sold, we would really recommend testing your specific raw materials to make sure you're designing the process the right way with the right pieces of equipment. I think most of you know these numbers, but as sort of a reference for what we're talking about today, the common size ranges that you want to grind to for face brick would be sort of in that 4 to 12 mesh range. Architectural brick would be in the 10 to 18 mesh range. For ceramic roof tile, 18 to 30 mesh, and for ceramic floor tile, 20 to 70 mesh. Is that right, John? Good, he said yes. The basic types of size reduction methods, so again, kind of forget about the machinery, brand names, or anything else. Impact crushing is the idea of hitting something and breaking it into smaller pieces. Shear, tearing something. So when there's fibrous materials, you want to have an action that's depending on close clearances in a machine and can have the ability to rip or tear at the material. Compression crushing is used in the industry, squeezing something under pressure until it cracks or fractures. And then attrition is a little less common in the brick industry, but it's material hitting on itself and eventually breaking itself down. This list represents sort of the 80-20 rule. There are different machines that aren't on this list used in the brick industry, but this is by the vast majority of the plants that you all are operating will use the equipment on this list, which jaw crusher, roll crusher, feeder breaker, which we'll get to, impact crushers, cage mill, dry pan, and hammer mills. The jaw crusher is an example of a compression-style crushing machine. You get very modest reduction ratios. So the 2, 3, 4 to 1 type of reduction ratios has a very modest horsepower per ton or energy input with a 0.5 to 1 horsepower per ton. A jaw crusher would be used as a primary crusher. The real downside, if you have much moisture or plasticity, a jaw crusher can be a problem. And jaw crusher, I don't know what the opposite of a size reduction machine is, but you can really have some sticking problems. So there are some jaw crusher primaries. They're few and far between. Many plants many brick plants in North America were designed with roll crusher primaries. So a roll crusher, similar, reduction ratios. They're sort of modest, 5 to 1. Again, very low energy input, 0.5 to 1 horsepower per ton. This is essentially a big lump breaker. So in both a jaw crusher and a roll crusher, a lot of small material will just pass directly through. there's not going to be any additional reduction done. And then roll crushers do at times have some problems with wet and sticky materials. So that can happen. The roll crusher and the jaw crusher have something in common, that the low energy input, and the reason why you don't see a lot of plants being designed with roll crushers and jaw crushers anymore, it's not very common, you're not making a lot of product. So if you're trying to get in your target mesh range, and that, for face brick 4 to 12 meshes probably covers a lot of your plants here today, these machines cost about the same to install as other machines, but you're not making additional product in that first primary crushing step. A feeder breaker is it's sort of a mix between an apron feeder and a roll crusher. And I think there's some interest in this room. I think there's a couple brick plants that are actually using feeder breakers in their mines. So think of a bed of material that's going across an apron feeder or a belt, but this roll crusher, and the picture you can see, it looks like it's picks, looks like picks. It'll crack down the very largest pieces of material. So there probably is a place for this, again, in the right application. I took some of the crusher type of numbers with reduction ratios and horsepower per ton, because I'm not sure we want to call this a pure crusher, but this is a good machine, and it's something that if you're interested in talking a little bit more about it, there is a manufacturer of feeder breakers that's represented well in the brick plant. If you want to stop by our booth tonight, talk about it, I'd be happy to do that. Impact crushing, the idea of hitting something and breaking it apart, this machine really hits a lot of the sweet spots in terms of high reduction ratios with a very modest energy input, the 1 to 3 horsepower per ton, but you're getting up to a 30 to 1 reduction. So it's doing a lot of work on that material. This type of machine can be used for a primary, secondary, or tertiary crusher. So they've been installed in each position. And then the real revolution on this style of machine in this industry has happened since the mid-90s. And it allows production to continue in times of higher moisture. So if you're in the rainy season, or if you just have a wetter material, this machine internally is specifically designed for this industry, and has really helped save a lot of money. When we talk about cost reductions, I think a little bit later this morning, this machine has saved this industry millions of dollars over the last 15 or 20 years. The method of operation is very simple. It's a very open machine, and there's not screens or grates that hold material inside of it during the processing. The heated surfaces are really it seems simple, but nobody had done it before, sort of the mid-90s. And this was an industry kind of led effort. We actually had customers come to Stedman and say, hey, we need something better. So we actually partnered with customers and people in this room to help get this technology into the market. Cage mills are usually used in a couple of situations. If you're making ceramic roof tile, ceramic floor tile, or if you have a material in your feed in a brick plant, say lime, where you need to grind a little bit finer so you don't have lime pops, cage mill might be used. So there aren't many cage mills, but it's, again, an impact style crusher, getting very high reduction ratios, up to 40 to 1. You're starting to have to put more energy into it, so that 2 to 7 horsepower per ton range. It's generally a tertiary crusher. Again, wet and sticky material is not a problem, but most brick plants don't have to use cage mills. You're not going to need it. It's sort of a special case or finer grind products that use this type of equipment. Dry pans have been a workhorse of the industry for many, many years. So again, there's quite a few well-designed grinding rooms in the brick plant that had roll crusher primaries, dry pan secondaries, and hammer mill tertiary crushers. This is a Muller type of wheels traveling over a bed of material. And then there's a screen in the bottom of the machine that controls the output. Very kind of moderate energy input, 3 to 5 horsepower per ton. These are typically secondary crushers. Wet and sticky materials can be a problem. They're not always. I mean, these machines can have pretty good staying power, but they're not quite as productive as you start getting to higher moisture levels. But dry pans have been a good workhorse in this industry. Hammer mills are used less and less. Hammer mills are an example of tertiary crushers, typically. Some plants, as a side note, some plants will get into, if you have a real low tonnage plant, it might be suboptimal to do this, but sometimes you'll still put a hammer mill into a smaller plant because it doesn't justify using one of the other pieces of equipment. But historically, hammer mills have been used as tertiary crushers. You get very high reduction ratios, and I took some of that ratio off because depending on the size of the screen that's used in the machine to hold material in there, that really affects the reduction ratios. And again, wet and sticky materials can be a little bit tricky in a hammer mill, so that's a watch out. The different types of size reduction machine affect the particle shape. And these are things that industry feedback has given this to us in this presentation, but there are economic implications of each of these items. So impact crushing tends to produce a more cubical particle shape, and that shape can translate into benefits of increasing the extruder die life, reducing the power draw of your extruder, improving the life of your screen cloth, and also increasing the removal of your product through the screening process, so your screen efficiency will go up. And Bill Crone will talk about, or Scott will talk about that next from Midwestern. Modern grinding rooms are driven, the equipment choices are driven by economics. It's that simple. I mean, it's not a gee whiz thing, it's a money thing. So we need to produce the product that you need in your plant most economically. So a modern plant may select a jaw crusher or a Mega Slam impact crusher for a primary. Those machines typically just need to deal with larger feed, and that's not always required. For a secondary crusher, Grand Slam impact crusher and dry pans. And for tertiary crushers, again, a Grand Slam or a cage mill. So when we look at the process of crushing and what are the expenses related to it, these are all real common items that we look at to help customers sort of do an analysis of what's the best for your situation. The operating and maintenance costs due to labor, they can be very significant with your crushing equipment. And a lot of times, I think the first brick plant I went in when I joined Stedman 7 years ago, the person that took me through the plant said they hadn't been in their grinding room for a year. Well, they had people working out there for that year, but the management person hadn't been out there. You can't ignore it. So there can be quite a lot of money tied up. Wear parts, the grease and oil, some styles of machinery really consume a lot of lubricants, and it's sort of one of those hidden things because the plant manager and the guy squirting the grease into the machine, but we have customers that were consuming drums of grease a month at quite a high expense, and there's ways out of that. Power consumption, housekeeping, that's becoming more and more of an issue. So I think moving forward, we're seeing the adoption of more and more stringent standards relative to housekeeping. And one of the things that some of the higher energy input machines do generate some airflow. But you're going to have to control that in any situation. And when you look at the overall picture of how you design your grinding room, if you can do your grinding in fewer machines, it's not just fewer grinding machines, it's fewer conveyors, fewer transfer points, fewer dust collection pickups. So, we're aware of that, and the housekeeping part of grinding rooms will be more and more significant moving forward. Your process throughput, so grinding as much as you can in as little time as you can, and then the number of machines required in the process. Mentioned it several times, we don't sell crushers in a little box. They go into a process. We have to understand the whole process, and we work hard to do that. One of the really significant payback drivers for a modern grinding room is taking 2 or 3 machines out and putting 1 machine back. Testing is absolutely key to being successful with what you're doing in a new grinding room. Not just size reduction results, but understanding what the power consumption on your material is and getting those wear cost estimates in advance. It's not a one-size-fits-all. Clay is not clay. You guys all are very aware of that. Shale is not shale. And You really have to understand what your material is going to do in the equipment and make sure that's quantified, so before you launch off and make an investment in a new machine, you know exactly what you're up for. The industry experience matters. You don't want people reinventing the wheel. So there are a lot of machines that look similar to some of these I've shown you, but not all are designed the same. So understanding those differences and the finer points. And I would recommend talking to other reference customers. So I know from personal experience, our best salespeople at Stedman are actually producers. And we'll get into that in a minute with John Hewitt. So John's going to take over from this point. You're all probably familiar with Interstate Brick. John, if you want to make your way up here. Interstate Brick in West Jordan, Utah is widely recognized as one of the premier commercial brick manufacturers in the U.S. Established in 1891, Interstate joined the Pacific Coast Building Products family in 1990. The company's products are used in residential and commercial construction. They offer several distinguishing features that motivate architects and builders across the country to specify them. John?
Okay, so I think the theme for my talk today is going to be Think Happy Thoughts. And it was several years ago we put a Stedman in, and it was kind of pleasurable revisiting all our old pictures. This is just to start off. This is a job we did a couple years ago, last year. Really helped sustain us during this time. It's the City Creek project in Salt Lake City. Nice job for us. Grateful for that. Yesterday when my boss and I rolled into town, we saw our brick going up on the building. That was kind of a thrill too. So just before we get into our project, I'll explain how Interstate Brick works. Maybe we're a little unique. That's a map of the state of Utah. We have 10 mines all around the state, and a lot of them are kind of small. Our number one clay comes from the southwestern corner of Wyoming, near Evanston. So we blend all these clays together to make a lot of different colors. This is just a lot of our mines, the clay is sandwiched between layers of limestone, and in this particular mine, it's dipping at about 30 degrees, pretty shallow. So that limestone has to be blasted and removed. It'll probably get used as road base someday. So we move around. We use this set of equipment and move it around to our different mines. Track hoe and a dump truck primarily. This is another. Our materials vary. We have different kinds of clays. It's really the color we're looking for, mostly, and then the properties. So at each one of our mines, we kind of shoot for a 2-year supply of clay, and we like to mine every other year. We're lucky in Utah. These mines are so far apart, but we use these aluminum trucks that can haul 40 tons of clay at a time. So this is the one mine up in Wyoming that's really kind of typical of the mines back east here. We could, you could probably use a pan scraper here. It's really large and horizontally bedded. It's a fire clay. So the trucks come into the plant and get weighed in our scales. Then at the plant, we stockpile about a 6-month supply, because some of our mines are inaccessible during the winter. Then the way we do it is we use a loader, and we mix our clay mixes with the loader. Each one's about 4 to 6 different clays. So that would be for a red-bodied brick right there. And we have a shed, and we can pre-mix clays, so we have them on hand for jobs that come in. We can store it under the shed to help keep it dry. So this is what we had sort of when the plant was built in 1972. We have an apron feeder, and there was a single row crusher that went underground, probably about 20 feet, and then it came out of that tunnel up into our grinding plant. And this is the inside, the apron feeder and the chute that dropped down, and that's the single row crusher. And just like Chris said, the single roll crusher just kind of chewed on the material and broke up the lumps and stuff. And what we had decided on our project was to get a machine that could do more work up front and maybe unload some of the work being done downstream. That's the crusher underground. So this is kind of the layout of our grinding room. It's taken me years to sort of get my head wrapped around this. It's a big grinding room and what to do. We have these big silos on the side, and it's really two grinding rooms that are mirror images of each other. So, one can do one plant, one can do another. We have two plants. We've since added, there's two more screens on each side. But you can see inside we have these 4 pan grinders in there. And so the clay went through that single row crusher into those silos and then straight to the pan grinders before going to the screens. This is a picture of our grinders. Of course, this is a little lab version, but that's kind of how they work. They have the big wheels that roll over the material. So this is kind of a summary. Those are our screen banks, and that's kind of what the material looks like going up to what it looked like before and what's going into the Stedman now. And this is what we used to have before. There's the apron feeder. It dropped down. One of the problems we were hoping to get away from is that crusher was underground, so down at the bottom where it discharged, it would build up a lot of material, and it would just have to be dug out a lot. And that was kind of a hassle. So this is Stedman, and this was important. About the time we were doing this project, Stedman bought an engineering company, Innovative Processing Solutions, because we wanted a turnkey project. So they were able to do everything for us, which was really good. But so this is where that used to fall out of the apron feeder. We just put another conveyor up and put the crusher in a new building. But you can see it's all above ground. This is just another shot of their drawing, how it just sort of makes a bypass around and then comes back and joins that belt where it used to come out from underground. This is an old picture. This project actually, it takes us a long time to do a project, so I appreciate Stedman hanging with us all these years. This was from 1999 when we sent a sample of our clay to their test lab. And once we got the project approved, we went back and visited Stedman. That's the rotor this is all the parts as they were being put together in their shop, the conveyor belts, the rotor, the stand, and the Grand Slam crusher. Stedman did a great job of, planning everything. The whole project, laid it out. It went really smooth. We ran the whole time. We were able to. It didn't disrupt our production. So these are just some pictures. They found local contractors that poured the concrete and did the building. A great crew of guys came out and assembled everything and put it together. And went off really well. One of the things about the impactor, we did have to, we had a dust collector and we just moved it over for our old crusher, but really it was, the new crusher was making more dust, so we were lucky we had a larger dust collector we weren't using, so we put that in place. We also upgraded our bags, but no big deal. That's a little metal detector that's there to catch going into the crusher, although I don't think anything would really hurt it if it went in. So the bottom line of our project, and it really has been a good project for us, we use a lot less wear parts than we used to and less downtime. We're only on our 3rd set of these breaker bars in the 4 years we've had this. And really our wear was a whole lot less than what Chris predicted. I think he wanted us to feel good or something. But we basically get about a year out of these bars. there's a whole lot less maintenance. The guys, and this is stuff I got from our guys in the back. They like it a lot. A lot less grease and greasing. The machine is easier to access. It's not a confined space, which I think's really good. And I think even when you open it up, it probably can't be started when the hood's up, right? Am I getting some feedback? Oh, okay. One of the big things that'll probably lead to another phase someday is, and the operators told me this, it really doesn't require, an operator sitting there watching it all the time. And it doesn't hurt the machine to run dry. It'll just sit there and spin. So we have, right now, for our machines inside, we have an operator that has to watch them all the time, but this would really free up that person. And then something we never even anticipated, those big silos, since we're doing a lot more work up front and reducing all the sizes, we used to have material get hung up in those silos, but since we've put the machine in, we haven't had to go in there, which is another confined space in a dangerous situation. So we got totally out of that. Those haven't plugged up or anything. So it's really been a good project. And again, this is how the machine just flips down in that bar. There's 4 of those, and they just change them out, and they can be flipped around. One thing I learned about this machine, you do have to make sure when you put it in what you want it to do. Some people, if you rely on it to really reduce a whole lot, you have this gap setting between the bars and the aprons. And I guess the tighter that gap is, the more it's going to wear. So that would, but in our case, after we got the machine in, we actually were able to open that gap up some. And it's probably helped us, so the bars can get a little more rounded. But we are definitely getting a whole lot more work out of it, out of our grinding room up front. Another nice thing is the bars are the only thing we've had to replace so far. There's a lot of other wear parts, but they're all the same. And I think some of them may have worn in a couple spots, but you can just take another one from another area that's not worn and plug it in, just exchange them. That's worked well. So the next phase, so when we put this machine in, we were hoping to eliminate having to use 2 of those pan grinders, and we did. So now we only have to have 2 instead of 4. So the next phase will probably be to put, some Grand Slams inside, either 1 or 2, probably 1 on each side. And the guys in the back are really looking forward to that. And this is kind of, since I've been working in the industry about 20 years, I think the impactor, I call it the impactor factor, I think it is a novel idea that's kind of caught on. And how many of these things, Chris, are out there, do you think? 75 in the brick plants in the last 15 years. So, I think it's just that rotor's spinning really fast and the material just drops through there and it just whacks it on the way through. So it really doesn't have a chance, I guess, to plug up as bad. And somehow, I don't exactly know why, but the wear for us seems to be a whole lot less. So I think it is a great machine for our industry. So it's been a good project, and look forward to the next one when we can convince everybody of that. So.